Hello dear friends, this is the second video on the ECG. In the last video we had seen that how to calculate the rate, the rhythm. Now today we will see how to calculate the axis. Now we know that the left ventricle is the most prominent structure in the chambers of the heart. So if the person has got left ventricular hypertrophy, definitely the heart will tilt on that side. Hence the axis is important, and also the heart is slightly tilted towards the left. So how is the axis then? How do we calculate the axis? Now we should know that the normal axis of the heart, as shown in this figure, is minus 30 to plus 90. Minus 30 to plus 90. Now we have got multiple leads. We have got the standard leads. The standard leads, lead 1, lead 2, lead 3. As we know that in the lead 1, the left arm is connected to the right arm. So this is the lead 1. The left arm is connected to the right arm. This is the lead 2. The left arm, or rather the right arm, is connected to the left leg. This is the lead 2. And here is the lead 3, that is the left leg is connected to the left arm. Now listen here. The left arm is positively charged. The left arm is positively charged and the right arm is negatively charged. The foot is what? Positively charged. So the impulse will flow, or the vectors will flow from one positive terminal to the negative terminal. Now the flow of the vectors. How is the flow of the vectors? If we consider the vectors, see here, if the impulse, this is the heart, this is the electrode, and this is the output. Now if the impulse is going towards the electrode, now you will get a positive deflection. If the impulse is going away from the electrode, you will get negative deflection. I'll repeat again. If the impulse is going towards the electrode, you will get a positive deflection as seen over here. If the impulse goes away from the electrode, you will get a negative deflection as seen over here. But if the vector, it is going away from the electrode, means it is going tangentially. To start with, this vector, this force is coming towards the electrode. That's why you are getting a positive deflection over here. Now when it goes beyond the electrode, you will get a negative deflection. So here you are getting a positive deflection. Here it is going below the baseline, that is a negative deflection. And you are getting one positive and one negative. This wave is called as biphasic wave. So whenever the vector is going tangentially, you will get both deflections, half of the positive, half of the negative. This wave is called as a biphasic wave. If we consider the augmented leads, here the AVF, it starts from the pelvis, you can say, and goes towards the foot. This is the AVF. It will be directed towards the foot. That's why it is AVF. F means foot. And AVL, here from the umbilical region, you can say it is directing towards the left arm. AVL, that is the left arm. And AVR, it is going towards the right arm. So this is AVR. So here lead 1, lead 2 and lead 3. So if we consider all the leads, you can see over here the lead 1, the lead 2, the lead 3. A triangle is created. This triangle is called as Einthoven's triangle. This triangle is called as Einthoven's triangle. And what is the Einthoven's law? Lead 1 plus lead 3, you will get the lead 2. This is the Einthoven's law. The Einthoven's triangle and the Einthoven's law. Now then, actually, how to calculate the axis of the heart? Now listen, as we have seen that the normal heart axis is from minus 30 to plus 90. Now see over here, we have seen the graph, or you can plot the graph. This is the baseline, or you can say the x-axis. This is the lead 1. We calculate the lead 1, or we calculate the axis from the lead 1 and lead 3 or AVF. I prefer calculating the axis from lead 1 and AVF. See here, this is the lead 1 and this is the AVF axis, or the y-axis. Now everything on this axis, this one is a plus, this is plus. Understand? Got it. If you go on the left side, it becomes minus. So you can see over here, this is minus 180. So the normal axis of the heart is minus 30 to plus 90. So if we go over here, if the axis is from plus 90 to minus 80, that will be right axis deviation. Understand? This will be right axis deviation. From here 0 to minus 90, it will be left axis deviation, LAD. And if it is from minus 90 to minus 180, this is called as extreme left axis deviation. Extreme left axis deviation. So the normal axis of the heart is minus 30 to plus 90. Right axis deviation plus 90 to minus 180. Left axis deviation 0 to minus 90. And, or you can say minus 30 to minus 90. I beg your pardon. Extreme left axis deviation minus 90 to minus 180. Now how do we do this? How do we calculate the axis? See here. Now if we consider this ECG, we consider what? We consider the height of the R wave in lead 1 and the depth of the R wave, you can say, or the negative wave in lead 3. See here. Means for understanding purpose, we say this is the positive R wave and we say this is the negative R wave. Understand? Or the negative deflection or deep S wave. So the height of the R wave. Now we consider there is a thumb rule. There is a thumb rule. We consider the left hand as the lead 1 and we consider the right hand as a lead 3. Now we take up the R wave. If the R wave is positive on left side and if it is negative on the right side, that is the third lead. So which thumb is upwards? The left thumb. So this is left axis deviation. This is called as thumb rule. Means consider the left axis as a left hand. This is the right hand. The R wave as left thumb. S wave as a right thumb. Which thumb is up? The left thumb. So it is what? Left axis deviation. We'll apply the same rule over here. This is another ECG. You can see over here that the S wave is deep in what? The lead 1. This is the lead 1. And the R wave is upright in lead 3. So if we consider the lead 1 as a left hand and the lead 3 as a right hand, and we consider the R wave or the negative deflection as a thumb, see here. In the left hand, the deflection is downwards and the right hand, the deflection is upwards. So right thumb is up. So it is right axis deviation. You practice it few times and you will come to know it's not that difficult. If on the graph paper, you can also calculate the axis on the graph paper. See over here. If we consider this ECG, this one. Now here we can see in the lead 1, the R wave is quite tall. So you can say it is almost around 1, 2, 3. 3 big squares means it is around 15 small squares. So height of the R wave is around 15 small squares. And in lead 3, there is deep S wave. It is around 10 small squares. So if we take that these are 3 big squares, and in lead 3 there are 2 big squares. Understand? So we can draw it on the graph paper. So for example, if this is a graph paper, this is the x-axis, which is the lead 1. We draw the lead 1 over here, and this is the lead 3. Understand? Got it? Now for example, this is around 3 small squares, so I take 3 centimeters. 1, 2, 3 arbitrarily. So 1, 2, 3. So if I draw, because this is positive, so here this is the lead 1. Got it? Now what happens in lead 3? 2 small squares, or 2 big squares rather, but it is negative. It is going down, no? So in lead 3, this is the positive side. It is a bit different in when you talk about the electrocardiography, and this is the negative side. So here we have to draw 2 big squares. So here this arm will be like this, 2 centimeters. We are taking it arbitrarily, but the distance should be almost the same. Now this is the lead 1. See, this is covered. The deep S wave, this is also covered in this limb. Now see the angle. So the angle will be like this. Got it? So this falls in which axis? This falls in the left axis deviation. Left axis deviation. Let me tell you students, this is also a crude method. Understand? But it works. So this is the left axis deviation. Now if we consider the right axis deviation, see over here. If we consider this axis, or rather this ECG. Now in this ECG, what you can see, here the S wave in the lead 1, not as compared to this ECG, here the S wave is deep. Got it? In the lead 1. It is around 2 big squares, that is the 10 small squares. Got it? Here the S wave is deep in lead 1, and in lead 3 the R wave is around 2 big squares. Understand? So according to the thumb rule, left arm, right arm, so it is right axis deviation. Right axis deviation. Now 2 big squares, for example, here also 2 big squares on negative side. So lead 1 will draw negative. Here lead 1 is negative, so it will come here around 1, 2, the negative arm. Understand? So this is the lead 1. Lead 2 is what? Positive. Lead 1 is negative, and lead 2 is what? Lead 3 is what? Positive. So it will come over here. 1 and 2. Got it? So see the angle. So the angle is over here. This is right axis deviation. Right axis deviation.